The students are self-discovering all the different combinations to create 24, using 1 inch by 1 inch cubes to create different box sizes, therefore helping them further understand the concept of volume.
24
by what?
2.
By 2, right? 24 by 2, and what do you get? You guys with me?
Yes.
How many people are confused or don't know how that works, or is this helpful to see it like that?
Yes.
Okay, kinda. Okay, what we're really trying to show you is that, hey, if you know that 4 groups of 12 equal 48, well then you also know you can take 24 of those and group them differently and put them into 2 by 24, and they must equal what? 48. They have to equal 48. We haven't taken away any, right? In this lesson, students will be using building blocks to construct different size boxes. The context is they work in a box factory. They're attempting to ship 24 oranges. The idea is that if they can understand that boxes can be constructed with different dimensions and still have the same volume, that they can understand volume and length and width and height better. It's in a box, right, but what else do we see here with the oranges?
It looks like the background.
It looks like the background. Okay, something about the oranges, that's true. Lexi? An array, yeah. How many people see an array in there? Yeah. And so what's that? Can anybody tell me the array that they see? What array is it?
16.
A 6 by 2. So you see 1, 2, 3, 4, 5, 6 by 2. A 6 by 2. How many oranges is that?
12.
12. Okay. So I got a 6 by 2. Does everybody agree?
Yes.
Now, what about this? Does that change it? Jonathan, what do you think? Now what array is it?
6 by 2 by 1.
Oh, it's 6 by 2 by 1 because it has one. This is what it looked like when my friend ripped open the box. All right, what do you guys see now? Yeah, now think about it. Tell your partner what's the array that we see. Got it? Tell me.
6 by 2 by 2.
There you go, good. Good. How many people heard your partner say that it was a 6 by 2 by 2?
Yeah.
How many did we get there? 6 by 2 is 12 times 2 is
24.
24. Good.
Surface area, volume, and dimensions. Building upon what students have learned already, we're now taking that, using the tool of the 3D printer to bring it to life. What this really does is help us with the math practice standards, the modeling with mathematics, the attention to precision with the measurements that they have to make, the perseverance. One of the things with a 3D printer is, depending on the plastic, depending on how it scales, there are mistakes. There's a lot of trial and error. So that persistence and problem solving is almost built in with the real world application of building these models. So students right now are printing this box, and they were given an object and dimensions of an object, and they needed to build a box that it would fit in. So ladies, what did you need to do when you had your object and you had to build the box around it? What were some of the things that you had to take into consideration?
The length and the width and the height.
Of the object, and then what about the box? What did that mean for the box?
The inside and the inside had to be bigger than the object, or else it would get crammed in there and it probably wouldn't fit.
Exactly. Very good. So when we found our box and you started scaling it, right, I gave you 5 millimeters. I'm sorry, 5 centimeters, and it was in millimeters. So do you remember how big you had to make the box?
Like around 50.
It was bigger than that, right?
50.18.
50.18 or something like that, so that the object would just fit.
There are 8 mathematical practices in the Common Core State Standards, which begin in kindergarten. As you have seen, what students learn about in 5th grade about volume leads to a deeper understanding of students applying and solving real-world mathematical problems on area, surface area, and volume in 6th grade.
5, 4, 3, 2, 1. Roller coaster.